Hello and welcome. Have you ever tried plugging numbers into an equation and suddenly everything just cancels out to zero? That's no accident. It means you've just discovered a root of the equation. Today, we are diving into a fundamental method for solving quadratic equations, factorization. Let's begin by understanding what a root really means. If we have a quadratic equation like x squared plus bx plus c equals 0, and if putting a certain value of x makes both sides equal, then that value is called a root of the equation. For instance, in the equation 2x squared minus 3x plus 1 equals 0, try substituting x equals 1. That becomes 2 into 1 squared minus 3 into 1 plus 1, which equals 0. So, x equals 1 is a solution or root of the equation. This also means x minus 1 is a factor of the quadratic polynomial to x squared minus 3x plus 1. The takeaway is roots and zeros mean the same thing in this context. Now, here's a beautiful link. If we know the roots, we can reconstruct the equation. Let's say alpha and beta are the roots of the equation. Then we can write the quadratic expression as a into bracket x minus alpha close bracket into bracket x minus beta close bracket equals 0. So, solving a quadratic equation basically means find the values of x that make the polynomial 0, and this is done by expressing it as the product of two linear factors. Factorization gives us this product form, and it's especially helpful when we can break it into easy-to-handle terms. Imagine it like breaking a puzzle into pieces and then putting it back together again in reverse. Alright, let's learn the method step by step. Step 1. Always begin with the standard form x squared plus bx plus c equals 0. Step 2. Multiply a and c. This product guides us in the next step. Step 3. Split the middle term bx into two terms whose product is a times c and whose sum is b. This is the heart of factorization. Step 4. Group the terms, factor each group separately, and take out common brackets. And finally, step 5. Set each factor equal to 0 to find the values of x. And there you have it, the roots of the equation. This is the method of solving by splitting the middle term, and it's efficient when the numbers allow easy factor pairs. Let's walk through an example together. We are solving to x squared minus 3x plus 1 equals 0. First, multiply a and c. 2 into 1 equals 2. Now, we need two numbers that multiply to give 2 and add up to minus 3. That's minus 2 and minus 1. Rewrite the equation 2x squared minus 2x minus x plus 1 equals 0. Group them 2x squared minus 2 smiley minus x minus 1. Now factor 2x into bracket x minus 1 close bracket minus 1 into bracket x minus 1 close bracket. So we get bracket x minus 1 close bracket into bracket 2x minus 1 close bracket equals 0. Solving this gives us x equals 1 and x equals 1 by 2. Isn't that satisfying? Let's highlight some key ideas. A quadratic equation like x squared plus bx plus c equals 0 can have at most two real roots because it's a degree to polynomial. When the equation is factorable, we can directly get these roots using the factorization method. And remember, this method gives exact solutions. It's quick and clean when you're dealing with nice, factorable integers. But sometimes, if the numbers don't play nice, you might not be able to factor easily. In such cases, we'll use the quadratic formula or complete the square. Still, factorization is a fantastic first method to try, especially in school-level questions. Ready for a slightly more challenging example? Let's solve 6x squared plus 11x minus 35 equals 0. First, multiply a and c. 6 into negative 35 equals negative 210. Now we need two numbers whose product is negative 210 and sum is 11. The pair 21 and minus 10. Rewrite the equation 6x squared plus 21x minus 10x minus 35 equals 0. Group the terms 6x squared plus 21 kiss smiley minus 10x plus 35. Now factor 3x into bracket 2x plus 7 close bracket minus 5 into bracket 2x plus 7 close bracket. So the factors are bracket 2x plus 7 close bracket into bracket 3x minus 5 close bracket equals 0. Solving gives x equals negative 7 by 2 and x equals 5 by 3. That's a solid example of how mid-dull term splitting scales up to harder equations. Let's quickly recap what we've learned. We started with the meaning of a root, a number that makes the quadratic expression 0. We learned how roots help in breaking down a quadratic into two linear factors. Then, we followed the 5-step approach: standard form, multiply a and c, split the middle term, group and factor, and solve for x. We solved two examples, from a simple case to a more advanced one, and saw how powerful this method is when the numbers cooperate. I hope this session has made the method of factorization clear and enjoyable for you. I hope this session has made the method of factorization clear and enjoyable for you. In the next video, we discuss the nature of roots, how we can predict whether the roots are real, equal, distinct, or imaginary using the discriminant. Stay curious, and I'll see you in the next lesson.